Okay, we're going to continue factoring the easy way. We're going to switch it up a little bit with our signs. And when I say the easy way, I mean the versions where the number in front of the x squared is a 1. That's the understood one. We also have an understood one here in front of the x. When there's no number in front of the variable, we understand that that's 1 because there is just one x there when nothing is there. So we're still wanting to add to get to the number in front of the x and multiply to get to the constant. So let's see how things are a little different. This is a minus sign, and that means my signs are going to be different in my answer. This plus sign tells you that the biggest number is going to be positive. So my answer is going to look something like x plus and x minus. So again, we're adding to get positive 1, multiplying to get negative 6. Let's look at all the possible combinations of multiplying to get just a regular old 6. 6 times 1, 3 times 2. So now let's look at our signs. Our signs are different. Our biggest one's going to be positive, which means our smallest will be negative. So both sets of numbers multiply to get to negative 6, but which set adds to get to positive 1? And that's the 3 and the negative 2, because 3 plus negative 2 is positive 1. So my answer is x plus 3, x minus 2. This one, we're still adding to get a negative 1 there. Don't forget the understood 1. Multiplying to get a negative 6, but we won't worry about those signs yet. Let's look and see what's going to happen to our signs in our answer. That just makes it easier. We have a minus sign, so our signs are going to be different. Here we have a minus sign, which means that our biggest number will be negative. So again, our answer is going to be in the form of an x plus and an x minus, since my signs are different. Now let's look at all the ways I can multiply to get to 6 again. 6 times 1, 3 times 2. My signs are different. The biggest one's negative. That means the 6 is negative and the 3 is negative. Both sets of numbers multiply to get to negative 6, but this is the only set that adds to get me negative 1. Negative 3 plus 2 is negative 1. So my answer is x plus 2, x minus 3. Again, adding to get 5, multiplying to get 6. Have a minus sign here, so my signs are going to be different. I have a minus sign here, which means my biggest is going to be negative. So my answer is going to look like x plus, x minus. Look at all the ways of multiplying to get 6 again. My signs are different. The biggest one is negative. Which one will add to get me a negative 5? And that's the negative 1. I'm sorry, the negative 6 and the positive 1. Because negative 6 plus 1 is negative 5. So my answer is x plus 1. And then I get an x minus 6. One more example. Moving right along. Adding to get to 7, multiplying to get to 6. Signs are going to be different. Biggest one is positive. So I'm going to have an x plus, x minus. Multiplying to get to 6. 6 times 1, 3 times 2. They're going to be different signs. The biggest one will be positive. So that gives me a negative here. So which set's going to add to get to positive 7? I have 6 plus negative 1. That gives me positive 5. And I have 3 plus negative 2, which gives me positive 1. So have we done something wrong? No. When you can't find a pair that add to get to the number in front of the x and multiply to get to the constant, what we have is one that we call prime. It's unfactorable.